When did you last get a visitor? How huge was the visitor, and did it stay with you for decades? The answer is likely no, but according to NASA, our solar system has just received a huge visitor that will stay around for decades and is hurtling in the Earth's direction. What is this object that just entered our solar system? How large is it, and will it collide with and destroy our planet? Join us as we dive into how NASA just detected something massive that showed up in our solar system. Our solar system is huge, however, defining its size is more a matter of perspective. The diameter of the solar system can be defined as ending at the aphelion of the farthest planet's orbit, the edge of the heliosphere, or, if you like, the farthest observable object. According to NASA figures, the solar system has a radius of 4.545 billion kilometers and a diameter of 9.09 billion kilometers at the aphelion of the orbit of the furthest recognized planet, Neptune. However, this diameter may change if the dwarf planet Eris is promoted following further research. Sedna is 3 times further away from Earth than Pluto, making it the solar system's most distant observable object. It is 143.73 billion kilometers away from the Sun, giving the solar system a diameter of 287.46 billion kilometers. That's a lot of zeros, but breaking it down into astronomical units, Sedna is nearly 960.78 AU from the Sun, and the solar system is 1921.56 AU in diameter. 1 AU, the distance from Earth to Sun, is equal to 149,597,870.691 kilometers. Another way to look at the diameter of the solar system is to assume it ends at the heliosphere's edge. The heliosphere is a bubble in which the solar wind pushes against the interstellar medium, and the edge of where the Sun's gravitational forces are greater than those of other stars. The heliopause is the term used to describe the edge of that influence, where the solar wind stops and our Sun's gravitational force fades. This happens at approximately 90 AU, which will give the solar system a diameter of 180 AU. As massive as the solar system is, it is a small portion of the universe. A countless number of objects exist outside the solar system, and sometimes these external objects enter the solar system and become our guests. The first interstellar object, or ISO, ever detected flew past Earth on its way out of the solar system on October 19, 2017. A second object, an easily identified interstellar comet known as 2I Borisov, was discovered less than 2 years later. The appearance of these 2 objects confirmed previous theoretical work that concluded that ISOs enter our solar system on a regular basis. Now, you might wonder how frequently these ISOs penetrate our solar system. Is it an everyday occurrence? According to a new study led by the Initiative for Interstellar Studies, I4IS, approximately 7 ISOs enter our solar system each year and follow predictable orbits while they're here. This research may one day allow us to send a spacecraft to rendezvous with one of these objects. In October 2017, the discovery of Oumuamua sparked a revolution in astronomy and the study of celestial objects. This was not only an object formed in another star system, but its arrival and detection implied a large population of such objects. And the discovery of 2I Borisov in 2019 confirmed what many astronomers had suspected: ISOs enter our solar system on a fairly regular basis. However, the largest ever interstellar object has entered our solar system. It all started in October 2014 in Chile's Atacama Desert. A telescope turned its gaze to the heavens and snapped a massive image of the southern night sky, capturing hints of reflected light. It would take researchers nearly 7 years to identify that strange dot of light as a massive primordial comet, the largest ever studied with modern telescopes. The comet was named Bernardinelli-Bernstein in June, and researchers are now trying to uncover as many details as they can of this massive visitor. Pedro Bernardinelli, a postdoctoral researcher at the University of Washington, discovered the comet with his then advisor Gary Bernstein during the final weeks of his PhD research at the University of Pennsylvania, hence the comet's name. So how huge is this ISO? According to the most recent estimates, the nucleus of this comet is about 93 miles or 150 kilometers wide. If stood next to Mount Everest, it would be more than 15 times taller. It is more than 15 times larger than the object that crashed into the Earth and triggered the extinction of the dinosaurs. This is by far the largest comet size estimate in decades. Comet 67P Churyumov-Gerasimenko, which was orbited by the European Space Agency's Rosetta spacecraft from 2014 to 2016, was only about 2.5 miles wide. It is basically jumping from city-sized comets to island-size. Comet Bernardinelli-Bernstein size may even put it on par with some historical great comets, such as a very bright and presumably massive comet that entered the inner solar system in 1729. But how did scientists manage to measure the size of this comet? Simply looking at its brightness, which is how much sunlight it reflects, will not suffice. This is because a large and dark object from Earth can have the same brightness as a small but shiny comet. So the astronomers measured the comet's thermal flux, or how much heat it emits. They accomplished this by observing a type of light known as infrared. Although it is not visible to the naked eye, we can feel it when the sun shines on our skin. A larger object absorbs more sunlight and then radiates it out. This data, combined with the object's distance, provided scientists with a good estimate of the comet's size. And this comet is staying around for a while. Bernardinelli-Bernstein will become brighter over the next decade as it approaches the inner solar system, dive-bombing the planes of the planet's orbits from below. It will make its closest approach to the Sun on January 21, 2031, when it will be about 1 billion miles away, slightly further than Saturn's average distance. It will then begin its long journey back into the solar system's outer reaches, where it will remain visible until the 2040s, if not decades longer. Bernardinelli-Bernstein could shine as brightly in the night sky as Saturn's largest moon Titan, depending on how much gas the comet emits as its ice is vaporized in the sun's glare. If this is the case, the comet should be visible in 2031 with a good backyard telescope. Amateur astronomers are going to have a field day with this. Bernardinelli-Bernstein, on the other hand, is notable for how far it was from the Sun when it was discovered. The icy object is part of the Oort cloud, a massive spherical haze of objects that surround the Sun thousands of times further out than Earth. This comet will take millions of years to circle the Sun, according to astronomers. Only 3 such long-period comets have been discovered on their way in from the Oort cloud, and Bernardinelli-Bernstein was discovered while it was still more than 2.7 billion miles away, a comet record. Because it was discovered so early, a whole generation of astronomers will have the opportunity to solve its mysteries. Bernardinelli-Bernstein was discovered by a highly sensitive digital camera installed at the 13-foot-wide Blanco telescope, which is part of the Cerro Tololo Inter-American Observatory in Chile's Atacama Desert. This camera wasn't looking for distant solar system objects, rather it was the primary source of data for the Dark Energy Survey, a project that collected 80,000 exposures of the southern night sky from 2013 to 2019. This dataset has changed scientists' understanding of dark energy, the mysterious force that propels the universe's accelerating expansion. Images captured to study dark energy and other cosmic phenomena, on the other hand, can be used to discover objects much closer to home. Bernardinelli's PhD research goal was to use dark energy survey images to find previously unknown objects orbiting the Sun beyond Neptune. This was an extremely difficult task. Because each image was so large, displaying even one at full resolution would necessitate a grid of 275 HD televisions. Bernardinelli combed through tens of thousands of these images looking for small dots of light, the proverbial search for a needle in a haystack. Bernardinelli, however, found a shortcut. He wrote computer code that looked for dots that moved against the backdrop of distant stars in the dark energy survey images. 6 months of arduous calculations on a cluster of 200 computers at Illinois' Fermi National Accelerator Laboratory resulted in a final list of 817 newfound objects whose orbits did not match any known body in the solar system. Bernardinelli and Bernstein manually checked this list as a final step to ensure that the code did its job correctly. That was when they noticed it, an object as bright as some of the 100-mile wide worlds beyond Neptune, but with an extreme orbit, implying it must have formed trillions of miles from the Sun, much like a long-period comet. Bernardinelli and Bernstein sent their comet evidence to the Minor Planet Center in Cambridge, Massachusetts, which serves as the world's official repository for the orbits of comets, asteroids, and other small bodies in the solar system. The center confirmed the object was a new discovery on June 19th. 5 days later, the comet was confirmed to be Bernardinelli-Bernstein in honor of the duo. The discovery of the comet spread quickly. In a matter of days, astronomers all over the world began pointing their telescopes at the approaching object and scouring their archives for any previously unseen images of it. Researchers quickly discovered the comet hidden in archival data dating back to 2010, improving the accuracy of its known orbit. Within 24 hours of the announcement, multiple teams of astronomers confirmed that the comet was emitting enough dust and gas to form a visible coma or tail, despite being more than 2 billion miles from the Sun. Of note is that comets don't emit much material until they approach the Sun's heat, which causes frozen compounds to sublimate directly into gas. However, Bernardinelli-Bernstein appears to be abundant in gas-producing volatiles that begin to sublimate even in the frigid space beyond Neptune. The observations indicate that the object could not have spent much time baking in the inner solar system in the past, making it appear pristine. Images taken in 2018 and 2020 by TESS, NASA's exoplanet hunting space telescope that also captured images from the incoming comet, provided more information about its tail. Surprisingly, the comet appeared much brighter in TESS data than it did in dark energy survey images. The team realized that TESS pixels covered much larger areas of the sky than dark energy survey pixels, implying that the comet was ejecting a massive, extremely diffuse tail. Bernardinelli and Bernstein combed through the dark energy survey data, stacking many images of their namesake comet in an attempt to identify the comet's tail. They eventually discovered an extremely faint signal in their data and discovered that the comet had begun emitting gas as far as 2.4 billion miles from the Sun, nearly 40% farther out than Uranus is on average. Bernardinelli's team could then begin to model the comet's chemistry by tracking how the coma changed over time and how much brighter the comet became as it got closer to the Sun. Given how weak the sunlight is at this extreme distance, the comet must be emitting carbon dioxide or nitrogen gas, they discovered. So what is the immediate future of this massive visitor to the solar system? Scientists are already speculating on what it would take to send a spacecraft to Bernardinelli-Bernstein. If the world's space agencies move quickly enough, a mission could intercept the comet in 2033 if launched by 2029. Researchers are also working hard to decipher the comet's previous journeys through the solar system in order to determine how much it has been altered by the Sun. According to Bernardinelli and Bernstein's calculations, the comet will be the closest to the Sun in at least 3 million years in 2031. However, delving deeper into the past is extremely difficult because Oort cloud comets are so far away their orbits can be shifted by passing stars, so modeling their orbits necessitates tracking the motion of stars through the Milky Way. According to new information, one particularly troublesome star could sabotage any efforts to determine the comet's orbit. Researchers have known for several years that about 2.8 million years ago, a Sun-like star called HD 7977 passed by the solar system. However, no one knows where it flew by. Researchers discovered that we don't even know which side of the solar system HD 7977 passed through. And because of this uncertainty, the star's gravitational pull on Oort cloud comets is poorly understood, which could have significant implications for when Bernardinelli-Bernstein last ventured inward and how close it came to the Sun. And observations as the comet approaches may alter its expected size. The 93-mile estimate is based on the comet's current brightness as well as models of the dust and gas it emits. However, calculating comet size using this method is a difficult task. When models of a comet's outgassing are incomplete, the nucleus can appear larger than it is. However, one of the best things about Bernardinelli-Bernstein is that it provides astronomers around the world with a rare luxury: time. The Vera C. Rubin Observatory in Chile, which is not even opened yet, will be able to track the object for at least a decade, if not longer, starting from 2023. Let's hear what you think of this huge visitor to the solar system in the comments section below.